All right, let's go ahead and get started. Hi, everybody. I'm happy to be here on a full night of rest. I got here from Seattle last night, and I learned my hotel room had been canceled. But thankfully, the nice folks at Hyatt McCormick had some spare rooms, and they were able to hook me up. So I got a good night's sleep, and I'm awake for our talk today. So what we'll be talking about today, make sure you're in the right place, is Azure API apps. I like to think of them as API backends that can power a bunch of different kinds of apps. In this talk, we'll focus on web, mobile, and logic, but also some classic, WinForms and console apps. We'll cover the full spectrum. My name is Mohit. My Twitter alias is Mohit as well. I signed up for Twitter really early. And I'm also here with Brady Gaster, who's in the front row. So if you have any questions, we can tag team and handle those after the talk. In fact, lots of the demos I'm going to show today are Brady's demos. All right, so we'll start off with just highlighting some of the challenges with consuming and authoring APIs today. And that's baselined against the offerings in Azure already. So we assume a baseline of Azure Web Apps or Azure API Management, and still talk about some of the challenges. The next thing we'll do is we'll talk about API apps. We'll give an overview. We'll talk about architecture. And I've already seen a lot of valid questions about how do I choose API app, mobile app, web app. Is API management the same thing as API app? Do they compose? Are they replacements? So even though I don't have slides for that, because that's kind of hot off the press, I've seen those questions coming up. So I'll take some time to speak to that as well. Then the bulk of it will be deep dives, and what we're going to do is we're going to build up an API backend. So it's a backend with a bunch of APIs that can power client apps, and we'll try and touch on all of the different kinds of APIs. So we'll start with the 101, file new ASP.NET Web API, and just see the delta between that and an API app, and publish that to the cloud. Then we'll add auth. Given the audience here, we're doing AAD today. Last time we did Twitter, but we'll do AAD today. And then we'll show how you can do what we call ad hoc SSO, which is get as close to an SSO experience even if your IT has not federated your directory with the particular SaaS provider you want to talk to. And we'll see how you can do all of that with almost no code, because the platform provides that for you. Then we'll do a little bit of non.NET stuff as well. We'll do some node examples. Then we'll build an API that connects to an on-prem SQL database. Then we'll pull some APIs from our Azure Marketplace that connect to SaaS. And by the end of the demo, or by the end of the talk, we would have built up an entire API backend spanning all of these different kinds of APIs. And then we'll drag and drop them into a logic app or a workflow. How many folks here have experimented with logic apps? Just curious. Okay. How many folks have used Azure Web Apps before? Okay, good. So I can assume baseline web apps. Some of the other stuff in App Service may be a bit newer. And then we'll talk about where we're going. Not quite a roadmap, but just some of the things that are top of mind based on the customer feedback we've gotten from you the last months. All right, so some of the challenges we hear from you around authoring APIs. The first one is, for example, ASP.NET MVC with the web API support is great. Azure Web Apps is a great host for web APIs, whether they be ASP.NET or Node.js. But there's still a bunch of stuff that is manual. In many cases, that's fine. But in many cases, we hear that customers don't want to deal with all of that manual plumbing. Some common examples are logging, auth flows, so that's both identity as well as SSO, storing secrets, storing config, and then also managing the update and versioning cycle. The next one is we're starting to see a proliferation of apps that talk to SaaS providers and on-prem, and they need to log in with social auth. Managing those auth flows can be very cumbersome. I'll say it in a conservative way. It can be very cumbersome. Another one is while there are API management products today, the integration between API hosting products like Azure Web Apps, for example, and our own API management product is still pretty ad hoc. And one of our top user voice items is, hey, why don't I just get the API management features when I publish an ASP.NET Web API to Azure Web Apps? Why do I have to manually do additional steps? And then finally, we're also picking up on the trend, dare I say microservices. I know that's a loaded term, and lots of teams in Azure are building stuff to help with microservices, but we're also picking up on trends where customers are building their backends with more single-purpose components. It's not always the case, but in many cases we're seeing this, and some of the benefits of single-purpose components are you can mix and match languages, you can be more agile because you can just change the things that you need to change. And then also, it can help with security and trust management as well. You can isolate the part of your backend that needs to be hybrid to just that single-purpose API instead of putting your entire API as hybrid. On the consumption side, consumption is difficult, especially once you add in all of these different auth flows we're talking about. Consumption is really difficult for pro devs, and it's basically impossible for business users without a lot of veneer on the top. Imagine what it would take without some plumbing or infrastructure to build a drag and drop experience to stitch across all the different SaaS providers that are out there today. Also, what I hear from lots of customers is we need to take control of our organizational APIs. We have a bunch of teams that have built APIs using different standards and different technologies, and that's fine. We're not saying necessarily we want to change that per se, but we want to at least be able to put some veneer on top or something on top to make sense of all of that. And then finally is APIs are often not documented, and I'll say we're getting better on Azure, but for most of you are Azure customers, even we struggle. The pace at which we rev our APIs often outpaces the documentation. So one of the questions is, why can't it just be one and the same thing? When I author my API, why am I not documenting my API at the same time? All right, so here's I'm allowed to use pink, I think, once in the deck according to the guidelines, so here we go. So what is Azure API Apps? It's really meant to address those concerns. We're taking the things we've heard, or the pains around building APIs, the pains around consuming APIs, and the pains around distributing and discovering APIs, and putting that into App Service and putting that into Azure API Apps. And our goal is for this to be something that is both cloud and on-prem. So if any of you saw the Azure Pack announcements today, we're making sure to architect this and all of App Service really so that it can run on Azure Pack, and or now Azure Stack. All right, so let's double click on how exactly API Apps addresses some of those concerns we just talked about. So the first thing that's really important is this is Web Apps++. So I'm going to show you in a second. There's a nice tool that lets you see everything in your Azure subscription, as JSON, and you can just see how everything fits together. It's really nice. It's called resources.azure.com. But what you'll basically see is everything API Apps is built on top of Web Apps. So when I provision an API app in the portal, I'm actually getting a web app under the covers, and the stuff that is done in API Apps is just incremental stuff. And in the future, we're actually looking to merge these things together even more, so the line between a web app and an API app might even go away. But that's not the case quite yet. And then everything else to the right on this slide shows the additional stuff you get. So we talked about access control, SSO, metadata contract. You're always free to provide metadata in your APIs. We have a very lightweight contract where we can know where your API endpoint is and then add value on top of that, like giving you the drag and drop experience in Logic Apps. We have a number of things for helping you build a bunch of small APIs and compose them together into a big API surface, and we have hybrid capabilities. On the consumption side, there's analogs. How many folks here have used Azure Mobile Services? Okay, smaller number. But Azure Mobile Services has a great set of SDKs that make it really easy to do auth across devices, and they do that by doing as much of the auth flow on the server instead of the client. Everything we do in API Apps uses the exact same technology. Same SDKs will work. In fact, the identity broker is the same identity broker here. Also on the consumption side, we've added code gen that understands the code, understands the metadata that we expose, and we'll talk about that. But it's a nice Visual Studio story where you can get both .NET and non.NET consumption for your APIs. And then finally, we have a gallery that will slowly be opening up. All right, so just to double click on what we mean when we say API apps is built on web apps, all the stuff on the left is Azure Web Apps. And everything that you can do with Azure Web Apps, you can do with API apps. So that means you don't have to worry about the OS. All the security features that are part of web apps are part of API apps. All the languages that are supported by web apps, so Python, PHP, Node, Java, .NET, I think those are the ones out of the box, and then you can bring your own so long as there's a good Windows story. So Wade Wegner, one of my colleagues, very proudly demonstrated Go working on web apps a couple weeks ago. And then for me, the most interesting piece is all of the deployment options are just part of API apps as well. So you can use web deploy, you can use Git, you can use FTP, whatever you want. And one key point on this slide, because I hopefully will address some confusion, web apps is GA. So if you're looking for a GA solution today for publishing APIs, web apps is the way. Everything that we're doing in API apps is currently preview, and we're excited for you to try it and give us feedback. But it is preview. So you're looking for a GA solution today. Everything on the left, web apps will give you a good way for getting APIs. The stuff on the right might simplify your life, but it is preview. So I just want to be very transparent about that. And we're updating our docs to make that clear if it wasn't clear already. Okay, I won't go through all the stuff on the right because we're going to do that in real time in a few minutes. But this slide is basically saying API apps is web app plus plus or something like that. Plus plus would mean two web apps. That's not what I mean. But huh? Web app sharp. There you go. All right. And then finally, I wanted to talk a little bit about the ecosystem piece. The ecosystem piece is there both to folks who publish APIs and want an additional distribution channel, as well as people who are consuming them. What does it mean today? Well, today it means that anything that shows up in the gallery will also show up in Visual Studio. And I've just ambiguously said business users tools, but you can assume Logic Apps is perhaps one example like that. And that currently includes Visual Studio, Logic Apps, and Azure Marketplace. There's more channels coming soon. And today this process is a very manual process. We have an email on our website. We'll soon make it something self-service where you can at least get your package into the gallery at a community level without having to email me or Brady or Guang or any of my colleagues. And then, after that, we'll have there's a certification step where once it's in the community, you can talk to us. We'll run some validation, and they can get promoted to get promoted. If any of you are familiar with the Azure VM Depot, we're following a very similar model to that. I think it's win-win because you don't want customers to expect community packages to be you want customers to know a community package is a community package to avoid them being disappointed. But once the verification is done, we're absolutely excited to promote partner packages. One implementation detail that might be interesting to folks here is these APIs do get deployed in customer subscriptions the same way that VMs do. And the way that versioning happens is something very similar to NuGet, which is a semantic versioning story. So anyone who opts into your API that's published to the gallery can say, hey, I want updates automatically, or I don't. And if you say automatic, we follow something very similar to NuGet. In fact, the underlying technology is based on NuGet. I'm not talking about this too much today because the self-service gallery doesn't exist yet, but just wanted to give you a little bit of a heads up of what's coming. And feel free to email us on the partner alias if you have an interest in being ahead of the curve. All right, so with that, we'll just go ahead and get started. This is the one blue slide I'm allowed to use. All right, and what we're going to do is we're going to just work up to a full API backend. I already spoke to what it's going to contain, and we're going to consume it from a bunch of different kinds of clients, both .NET and non.NET. All right, your first API app, and I hope I'm not insulting because this is the 101, and then we'll build up from there. I need to switch. All right, so this is really the first API app scenario. So I'm going to start up Visual Studio, and I'm going to go to File, New. Okay, within the web node, we still have the one ASP.NET dialog, nothing new here, ASP.NET Web Application. Okay, now we've added something new here, however. You'll see here that I have Azure API App Preview alongside Web API. Either way is actually completely valid for publishing an API app. If you're starting from scratch, the Azure API app makes some assumptions that are probably valid if you're going to publish as an API app. The big one is it disables authentication, the assumption being you're going to use the auth capabilities that are provided by API apps. Having said that, I could have just picked Web API, and that would be fine too. So I'll go ahead and pick API App Preview. Here we say Preview front and center. Okay, and what it's going to do is just create a very simple ASP.NET Web API after it pulls down all the NuGet packages it needs to. All right, and there we go. That's my API app. Couple things that are incremental to just a regular ASP.NET Web API. The first one is we've automatically added a NuGet package called Swashbuckle. How many folks here have heard of Swashbuckle? How many folks have heard of Swagger? Okay, actually a surprising number of hands for Swagger. So all that Swashbuckle is Swashbuckle uses the ASP.NET Web API help methods to reflect on your Web API and automatically emit Swagger. So we're just putting that in by default in this case.
Quick question.
Yes?
The templates that you use there, you're using Visual Studio 2013. Is that from the Azure 2.6 SDK?
They were first of it. The question is, what SDK lights up this feature? It was first lit up in what we call 2.5.1, which released on March 24th. And then 2.6 is a couple bug fixes, but no big new features in 2.6 as it relates to app service or API apps. Good question. All right. One other thing you'll see in here is a file called api-app.json. The most interesting thing in here is this API definition piece, and that tells us that, hey, look for metadata at this particular endpoint. And the nice thing about this is it gives you flexibility to put your endpoint where you want to. This is just the minimum amount that we need to know to be able to find it, to light it up in the Logic App Designer. The other stuff is less interesting right now. It becomes more relevant once we make the gallery public. Right. I'm going to do one more thing. Because this contains Swashbuckle, it also contains a file called swaggerconfig.cs. We, by default, turn off the Swagger UI or the Swashbuckle UI because we think folks might not appreciate a test page for their APIs just being available on the internet. So I'm going to go ahead and uncomment that just for the demo at least. And I'm going to run it locally first. Okay, this is fine because I actually don't have any MVC routes in here. I only have API routes. So I can go ahead and hit Swagger, and I get a test page with the list of all the operations. I can actually run them right here, get the outputs, and if I want the JSON, and that's why, by the way, that's why I'm using Chrome for this demo, because in IE it downloads the JSON, Chrome renders it inline. So I'd rather render it inline right now. There's the JSON. Okay, so now I'm going to go ahead and publish it. Okay, this is our usual web publish dialog. We've added, we've added a new item called Azure API Apps. We're actually thinking in the future we might just condense these two things back down to Azure App Service because they're really not that different. At the moment, they are different just because we want to indicate one is preview and one is not preview. So I'll go ahead and pick Azure API Apps. It's going to go through my subscription and find all the empty API apps or existing API apps I already have. So I provisioned one in this case. So let me go ahead and pick it. Hit OK. Now what it's doing is it's downloading the web deploy publish settings from Azure and pre-populating everything in this publish dialog, so I don't need to fill it in myself. Okay, I'm going to go ahead and do debug, and just to be safe, remove additional files, hit next, and publish. Okay, and this is going to kick off a web deploy publish, which I tried on the plane last night, and it didn't work on the plane, but I'm certain that was the Wi-Fi on the plane. I don't even know why they sell Wi-Fi on the. I'm not going to say which airline I was on, but it was basically useless. I couldn't sync my mail or anything. All right, huh? No, this is better. Believe it or not, this is better. All right, so the publish succeeded, and it should pull up the browser in just a second. And I get a message, which is what I would expect in this particular case. It says permission for service Azure cards is set to internal, but the request was external. All right, and that's because we polled customers and asked them what should we do by default when you publish an API app, and about half the folks, maybe a little bit more than half, say keep it internal. So that's what we've done. So it is a manual step to make it something other than internal. So I'm now going to flip to our Azure portal. So if I click on API apps, you'll see indeed I have this Azure Cards API app here. I can click on it, go to All Settings, App Settings, and pick the access level. It defaulted to internal. For now, I'm going to pick public anonymous. In a little while, we're going to come back and explore public auth, but I'm going to pick public anonymous just for now. Okay, an automatic update, because this is not a gallery package, it doesn't really make any sense. I'm just deploying it direct, so automatic update is grayed out here. So I'll go ahead and hit save.
So what does internal really mean?
Yeah, good question. So the question is, what does internal mean? Internal means registered with the same. I haven't talked about what a gateway is, which I'll get to in a second. But internal basically means same resource group, and so that means other API apps in the same resource group can talk to that API app. It means mobile app. It means another mobile app in the same resource group can talk to it. And it soon means a web app in the same resource group can talk to it. Having said that, there's nothing fundamental that constrains you to a resource group, and one big piece of feedback has been, I want this internal thing, which is basically shared secret across resource groups. So that's something that we're going to be putting on our blog post as a blog post soon and be building into the product a little later. But internal basically means there's some kind of shared secret between the two parties that are talking to each other, facilitated by the gateway. All right, so now let me go back to Chrome, refresh the browser. Okay, that's because I don't have a route there, but if I actually go ahead and hit like API values, there's my beautiful API value 1, value 2. All right, so now we're going to just to keep the talk interesting, I'm going to overwrite this slot with a more interesting API. And then we'll start adding features to it. We'll do cores, we'll do auth, and we'll kind of build from there. Actually, let me show you one more thing while I'm at it before we do that, actually. So I'm going to go ahead and hit I'm going to consume this from a console app as well. So add new project, Windows Desktop, console. All right, so one of the new things we've also added is the ability to generate clients that I alluded to. So I can go ahead and pick Add over here, Azure API App Client. That's Brady's wording. All right. And I have two choices here because we know that customers want this feature not just for Azure APIs. So if you've managed to get Swagger for an API that you have anywhere, you can just provide the Swagger here, and that's great. If you've hosted your APIs in Azure API app, we can interrogate it because we know what the metadata endpoint is, and we can just pull down the Swagger automatically. But this tool works just as great for APIs that aren't Azure API apps. So let me go ahead and pick our Azure cards and hit OK. Yeah, we love your feedback on this feature, both on the experience and just the quality of the generated code. We've tried to be very transparent about the generated code, so what you'll see in a second is in this, where did it go? Console app. In the Azure Cards folder, you'll see that there's really no magic. These are just wrappers on top of HTTP client, and we haven't hidden that behind a DLL. It's just source code in your project. So if the generation is not to your liking, you can change it. You can add extension methods, whatever. So let me just go ahead and use it. So I'll say var cards equals new Azure cards. Cards dot values. Okay, so for each var value in cards dot values. Console. Right line, whoops. Wrong startup project. Oh, .get. Thank you for being in the audience. That's all right, there we go. Okay. So there, very nice experience on top of web APIs, and you'll see the principle we've used roughly. If I zoom in here, each one of your controllers gets this sort of property, and then all of the actions hang off of the property. So we try to model it pretty closely to what you'd be familiar with if you use something like ASP.NET Web API. I'll show you later generating Python and non.NET, but later. All right, so now let's open up another project, a little more interesting one. And this is also an API, but the API controller here is around cards. So it will let me. It has an API for granting me a new deck. Once I have the new deck, I can choose to shuffle. And I found the shuffling algorithm a little bit suspect, but we'll let that go for now. And then I can select cards. I can deal cards. I can say how many I want. So you can imagine this being an API that's kind of interesting, an interesting API on top of which you could build additional games. So let me go ahead and publish this to the same slot that we just had. So publish Azure API Apps Preview. All right, next. Let's do debug again. Overwrite files. Next. And publish. All right, so I'm going to start talking to this while it's publishing. So what it's going to do is publish an API. This particular API also happens to have HTML, a static index HTML with Angular code in it. And that's fine. There's nothing that says with API apps you can't host HTML, so that's what we're doing here. So this particular app, once the browser launches, because I've already marked it as public, should actually launch. And because I have an index HTML, it will actually render UI. So hopefully in a couple more seconds, we'll see that. Yep, there we go. Okay, so what I can do here is I can say new deck. It creates a deck. Once it creates a deck, I can say shuffle. And then I can say deal. I thought that was going to be worth an applause, no? That's all. Those are all Brady's. That's Brady's doing. We're actually thinking of printing them out and giving them a swag at some point. We're not there yet. All right, so now let's try something a little different. So right now I have the API and the HTML in the same app, but maybe I don't want to do that. Maybe I want to have my HTML in one web app, and my API in a different app service or a different API app. So let's do that and see what happens. So I'll flip back to VS. Remember to switch my startup project to web app. Okay, and this is even though it says web app, I think it's all client side. It's all client side code. It's an index.html with some Angular in it, and all the calls to the API are just done from the browser. It's all, you can see here, it's all being done using Angular right inside the browser. So let me go ahead and run this. And I'm going to open up Developer Tools and look at the console, and I'm going to click New Deck. Okay. What's happening here? So what's happening here is just basic cores. It's saying that, hey, you're trying to access an API from within the browser from a different domain than the domain that the browser is hosted in. You can't do that unless the API grants that domain the right to be able to access it. So there's a couple of ways you can do this. For those of you familiar with ASP.NET Web API, there's a very robust cores story that's just built in, and that's fine. But we hear from customers that oftentimes they want to change their cores using config, or they're using a framework that doesn't have as good support as ASP.NET does for cores. So we've added the ability to add cores support right on top of your API. I'm going to show you that in just a second. So I'm going to flip back to the portal. There's a funny thing in the resource group called the gateway that I'm going to speak to in just a second, but I'm going to click for now, just take my word. I'm going to click on the gateway, and on the gateway you see this thing called gateway host, and that's because the gateway, just like the API apps, is just an Azure web app under the covers. So I can go ahead and click on that. Have it load. I'm allowed to blame the network. That's what all presenters do, and you guys gave me the opening to do that a few minutes ago. App settings. Okay, and I can add a config setting here or an app setting here. I never remember what it is, so I have to look this one up on my iPad. We're going to make this a built-in control. It's just not built in yet, so it's a config setting. MS cross-domain origins. And I can paste in the URI of my local host, which is https localhost 44308. All right, and hit save. Okay, success. So now if the demo gods cooperate, and I flip back here, let's control F5, hit new deck. Okay, you see it's taking longer. That's a good sign. That means that the config setting resulted in the gateway being restarted. So you have the ASP.NET warm startup or cold startup going on here. And the deck created with no error message here. So I can shuffle and deal. So we find that customers are excited about this feature, especially for development scenarios, because they might be deploying APIs to a bunch of different environments. And this is a config way of setting cores policy. And everything I'm showing in the portal can be done with APIs and with PowerShell. So So that's the key idea here. It doesn't prevent you from using the built-in cores in ASP.NET if you like that. This is just another way of doing it. All right, so let's go back to slides for a few minutes.
Yeah, I want to see that shuffle.
You want to see it shuffle again?
Straight flush right there.
Oh, yeah, that's why I told you I'm suspect. If you have a concern with the shuffling, it's this guy right here.
Hey, work it on GitHub if you don't like it. No, we like it.
I think I was on 5. All right. So there you go, your first API app.
I had a question.
Yeah, question.
Is this enabling it on the Azure portal, does that override if you're using ASP.NET enabled cores packaging?
Yes, it's one or the other. So yeah, this will win over what you've configured in ASP.NET. That's correct.
What if it's a public-facing API? How are you going to enable cores for the public? So if my API is to be hit by anyone on the planet?
Yeah, I'm going to talk about permissions in a second, but you can with API apps, just like web apps, you can make them public, or you can make them secure. Either way, you can put cores. Cores is kind of a separate concept. Cores is a separate concept from the access level of your API. It's just there to it's there so that me as the owner of an API, I only want people I trust to embed my API in their web browser, because otherwise people could, bad site could call the API and then that a customer is logged into, get access to the payload, which might be financial information, et cetera. So that kind of manages the domain level access, which is different from.
Access to public, and still you were able to hit from the other local.
Yeah, that's how cores. That's how browsers work today. That's not anything specific to API apps. So that's what I'm saying. The access level public or authenticated or private is one concept. Cores is a different concept. The two things can certainly be used together. All right. So taking a step back, API apps is part of App Service. How many folks here went to other App Service talks? Okay, about a third. This is the picture that Hanselman put together that I like, because lots of our marketing, at least early on, made these things all equal. And I think this is a helpful picture. At the end of the day, the APIs are there in service of other apps, so web apps, mobile apps, logic apps. Having said that, it can be just clients as well. So in some sense, this picture is incomplete. You could have other clients as well. But I think this helps put it all together. And I can certainly do web apps and mobile apps without API apps. I opt into however many APIs I want. Okay. Here's a bit more in-depth architecture. I'm going to walk you through this. Let me see if my mouse pointer works here. Okay. I'll talk you through which part of the diagram I'm speaking to. So let's first look at the big thing in the. Let's first look at the center, the gray box in the center, the resource group. So the resource group roughly represents your app. So a number of other sort of backend as a service providers that are out there also have the concept of an app. And the app is where you hang app-specific kinds of things, like maybe client IDs and secrets. So because Azure already has the notion of a resource group, we didn't want to invent another container. So things that are related to your app all live in the same resource group. So what can live in that resource group? Well, you can have API apps from the gallery. So I'll show you later when I do logic apps. You'll see me pulling down apps from the gallery like Salesforce and Office and Twilio. It can include custom code. So it can include mobile app, which some of you have used or used mobile services. It can include direct deployed APIs, and it can include logic apps. All of them can just live together in the same resource group, and each one is under the covers running as a web app, with the exception of logic apps. Sorry, mobile, web, and API all are just web apps under the covers. On the left of the picture, you basically are seeing the technology that implements the auth flow. So if you choose to do auth, what happens is you log in through something that we call the gateway, and one of the key features of the gateway is an identity broker. And if any of you are familiar with mobile services, it's the exact same concept. So I basically say gateway.login, and I say, hey, I want to log in the user with AAD, or Facebook, or Twitter, etc. Then what happens is one of two flows, either a server flow or a client flow, which I'll talk about in a few minutes. But at the end of the dance, a token associated with your identity provider gets dropped in the token store. So that could be an AD token, it could be a Facebook token, etc. But then what flows between the client, like a web or a mobile client, and the backend is a Zoom. It's called Zumo because it's the same technology as mobile services. The code name for mobile services was Zumo. We didn't want to change things. So what actually flows between the client and the backend is a Zumo token. And the nice thing about that is then later, if you need to SSO into other services, you just have to hang one token on the request back and forth. All the token management lives on the server.
Is the Zumo token just a variant sample too?
Yes. Yeah. And then you also see something called the consent server. And the consent server is kind of similar to the gateway, but it's different in two different ways. The first way it's different is in the problem it's trying to solve. The gateway solves login. I'm trying to log into this app, and I want to use my AD credentials. The consent server enables what we call ad hoc SSO. So it says I need the user who's logged in as Brady at Microsoft.com wants to use some functionality of this app that requires Salesforce. We don't have directory federation between AD and Salesforce, for example. So it gives Brady the option to enter his own credentials, and then the app can continue. And the consent server facilitates all of that. It facilitates the OAuth flow, and when Brady ultimately logs in, it facilitates Brady's Salesforce token getting dropped in the token store and associated with the AD token. I'll show you an example of that later as well. The consent server has two modes. For those of you who play with logic apps, for logic apps, you don't want every time somebody drags and drops a card into the logic app designer to say, hey, enter your Dropbox client ID and secret. Hey, enter your Twitter client ID and secret. That would just be very cumbersome, especially for non-pro dev kind of users. So there's a global consent server that lives in service just of logic apps. So if you want to use Twilio and Office and Salesforce, you can use this. You automatically just get the global consent server. Having said that, lots of our enterprise customers don't want to do that. They want to be in control of their own client IDs and secrets. They want access to the dev portal for Salesforce. They don't want to be victim of throttling that sets in because of of someone else sharing the same client ID and secret. So you have the option to specify your own client ID and secret. So when Brady logs into Salesforce, it doesn't have to be the one that's used by the global consent server. We can pick our department's own client ID and secret. So that's the bottom left. And then the final part is on the right. And all that the right is really saying is that because this is running in Azure App Service, same technology as Azure Web Apps, there's a number of on-premise or hybrid connectivity stories. And there's a number of things you can do for connecting to SaaS. Hopefully that helps make sense of that picture. This is just a double click on that app service gateway. I know a lot of questions have come up, and we're actually thinking about changing what we call this thing about, hey, doesn't APIM have a gateway? Now there's two gateways. This is a little bit different. Here, when you hit your API, you still hit your API directly. So when I earlier hit the Azure Cards API, I first hit the Azure Cards API, and then the Azure Cards API was, recognized that, hey, auth is needed here, or the front end recognized that, hey, auth is needed here. Internal, so like hidden from the customer, internal, the call got routed to the gateway to do the identity piece, and then back to the API app. So really, aside from that initial login experience and perhaps some management experiences, you don't really interact with the gateway. You interact directly with the API app. And that's very different from something like API management, where you interact exclusively through the gateway. So, one thing we're going to do in the near term to make that clear is we're going to publish some guidance on how to compose API management and API apps, because the two things really can live together. One gives you a facade that spans apps, spans resource groups, and even spans clouds, whereas API app for the most part is about building an app and servicing an app. So the two things are meant to live together and compose together. But one of the most common things I get is I need to take control of my APIs. I have APIs in multiple clouds. I have APIs implemented using different technologies. Is API apps right for me? And the answer is no. In that case, you very clearly want API management. As you develop additional APIs, you can also put those behind the same API management gateway. So this is what I'm talking about today is an API development and hosting story. API management is what it sounds like. It is a management story, and the two things are intended to compose together. All right. I think I've talked through most of what you see here, so we'll talk a bit more about auth. All right, so that gateway includes an identity broker, and the identity broker supports these different kinds of auth. It supports 3 access levels: public anonymous, which is what it sounds like; public auth, which today means log in with the identity broker and whatever auth providers are configured, like AD or Facebook or Twitter. Soon it will mean custom. That's one regression we had from Azure Mobile Services for customers who are familiar with that. Azure Mobile Services had a nice way of bringing in custom auth. We're not quite there yet. It's top of our backlog. And then there's internal, which we talked about, shared secret managed by the gateway. Public auth, today it's these 5. Custom is coming soon. We saw cores, and we'll see what we mean by SDK support in a minute. But the key thing here is as much of the work as possible happens on the server to keep the SDKs as light as possible. In fact, I'll show you one example where I don't use an SDK. I pop a browser window and I just sniff the output, which is in the URI, and I can be logged in. Okay. For those of you who've heard of mobile services or use mobile services, this shouldn't be a surprise. There's 2 flows, server flow and client flow. Server flow is the easy flow, if you will. That's where you say, hey, server, you take care of everything for me. In many cases, that's the right thing to do. In some cases, it's not the best thing to do. In AD in particular, AD for certain devices has a pretty robust set of features around device management and device identity. So if you want to take advantage of that, you can certainly use ADAL and log into AD however you do today. And then you just give us that token and get back a Zumo token. So you're in charge of the AD token in that case. Either model is fine. It depends on what you're optimizing for. Or even for some devices, you might go with client. For other devices, you might go with server, and that's fine. That's fine too. And we talked about what we mean by ad hoc SSO. All right. This slide is not a pretty slide. I apologize, but the colors are different than what I thought I had given. But anyway, what all this slide is saying is these different access levels. You can imagine how these different access levels allow you to build different kinds of architectures. So you could build an architecture where all your APIs are internal, and all you expose publicly is like a mobile backend, aka mobile apps, web backend, or some Uber API app backend, and that's fine. I think many customers prefer an architecture like that where there's really one face, and everything else are just services in support of that face. Lots of our mobile app customers adopt this pattern. They build a mobile app mid-tier. They don't want to put all the logic in the mobile app directly, so they build up a bunch of, I don't want to use the word microservices, but maybe I have to here, mini services, but ultimately expose them via a mobile app. The right-hand side is saying, hey, if you want, you can expose these APIs directly. That's why we have the public auth support. So if your APIs have already been designed in a way that they can just be consumed by authenticated customers, you can do that directly. And that was my HTML and JavaScript example. Or you can use them in logic apps, which to some extent sidesteps both of these things. That's why there's no label there. All right, so let's do AD. How many folks are sort of actively using AD in some capacity? Okay, half. How many folks would say they're experts at AD? How many folks would say it's a pleasure to work with AD day in and day out? Okay. No, I saw one hand. No, AD is very powerful, but I think AD is very powerful and very capable, but with that, admittedly, comes a bit of a learning curve. So we've tried to streamline some things with AD, and I'll show you that. All right. And what I'm showing you is not really specific to AD. It's any of the social providers I told you about would work the same way. All right. In the interest of time, I'm not going to go through all the steps. I'm going to just show you what I've provisioned already. So this is the Azure portal. This is the current Azure portal. So I went ahead and I created an application already in a tenant that's poorly called Microsoft. It's really not the Microsoft tenant. It's a tenant for contosaweb.net. Okay, and within here, I went ahead and created an application. If I go ahead and say configure, you'll see that I get a client ID associated with that. And I also provided a reply URL and app ID URI. So you might be wondering, how did I figure out what that reply URI is? Because that's really one of the most important pieces here. That's the thing that handles the callback from AD. And normally, if you're using ASP.NET, you'd have to implement that callback yourself using like the Owen pipeline. So let me flip back to the other portal. All right. And we're back at our gateway. And the first thing you can do on the gateway identity. All right. So the gateway tells me right in the portal what app ID to paste into to Azure AD and what reply URL to paste in. We're hoping to make this a single button click in the future, but at least today the information is just front and center. It also gives me a place where I can paste in the client ID. So that's the client ID that I just showed you in AD. And it gives me a place where I can enter my tenant. So this is single tenant, so I just entered one domain. So that's on the gateway side. On the API app side, on the API app side, if I go to all settings, app settings, I'm going to change the access level from public anonymous to public auth. So now if I tried to hit that API, I would get a message similar to what I got earlier, which is access level is set, it's set internal, but now it would probably say public auth. You need to log in. So there's a couple ways you can log in. The first one is you can log in actually right from the browser, and that's a really handy way to make sure that things are configured correctly. So I'm going to copy this URI, and I'm going to open an in private session because I'm already logged into the Azure portal with one set of AD credentials. The tenant for my app is a different tenant, so I can't use the same AD credentials. So I'm going to open up a separate browser window. All right, so I'm going to hit it. And then what I have to do is I have to put in /login / the name of the provider. So in this case, it's AAD, and hit enter. Oh, must have typed in something wrong. /login / AAD. Oh, sorry. I have to put in the address of the gateway, not the API app. My bad. So let me go back to the gateway. Gateway. Copy the URI. Try again. Login, AAD, HTTPS. All right, now if I hit enter, there we go. It's redirecting me to the AD login screen. So I go ahead and log in. I'm going to log in as Carla Davis, my alter ego. I think that's the word. ContosawWeb.net. Okay, it's redirecting me to my organizational sign-in page. I was about to recite my password. I'm happy I remembered not to do that. Okay, and I'm logged in. And let me zoom in here. One thing that's really nice is this is a very easy to handle way of getting the token back. So we put the Zumo token right on the URI. So if you're using a client that we don't have an SDK for, but you have the ability to pop a browser window, you can do what I just did in your browser window, and just check the navigation events. And when the browser, there might be two-factor or whatever, but when it's all done, you're going to end up on a URI which has this format: /login/done #token equals. And that's your Zumo token. So you can then take that token, save it in whatever the right place is for your platform of choice, and then flow that token in with all your requests. So where we have SDKs, you don't need to use this. But if there's a platform where we don't have an SDK, you can basically sniff the browser window and or the browser control and do this. So I'm logged into the browser. Let's look at some other examples. Okay, so let's open up a Windows Store app. And I need main page. Can folks see this in the back? I'll zoom in again. Okay. So this is basically all I need to do on a platform where there is an SDK to log in. So I queued up an app service client. You can think of the app service client as the gateway client. I did login async. I gave it the auth provider, and notice that's a constant. That very well could have been Twitter. In fact, when Brady did this demo, it was Twitter, but given the audience, I thought AAD might be more interesting. And that's it. I think false means I'm not passing in a token. That's it. And then the SDK, because this is a Windows Store SDK, knows what that means. So it knows how to render a browser control in the right way. It knows how to capture that #token thing. It knows how to store it securely on the device. So those steps that I explained are done automatically by the SDK. But that's basically the essence of an SDK that can do login. So let me run it. Start a project. Control F5. Okay, this is basically a rendering on a Windows Store app of a browser control. That's what you're seeing here. I can go ahead and log in. It's redirecting me to my organizational sign-in page. I hit sign in. There are lovely cards. Yay. With suspect, well, in fairness to Brady, I didn't say shuffle this time, but the Jack, 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 4-2, Jack, Jack, Jack.
Free shuffle. 10 times, actually.
Oh, really? Okay, so that's on Windows Store where there's a nice SDK. Just for fun, we did a Windows desktop app, and we just debated between WPF and WinForms, and we said let's just go with WinForms, and that's what we did. So let me show you that one too, but let me show you the code first. This one won't be as pretty, but I think it's still not crazy. All right, so let me go to web browser. All right, so let's walk through what's happening here. So the first thing I'm doing is I'm navigating the web browser control that's part of this WinForm to the same thing we've seen already, /login/AAD, off of the gateway. Okay. Then I'm keeping track of page loads in the web browser control. And when it has #token in it, I'm basically taking that payload from the URI that we saw earlier, and I'm storing the token in my app. Okay. And the token, if you were to, we didn't really double-click in it, but if you were to double-click on the token, you would actually see it contains two pieces of information. It contains a user ID and a user token. So off of that app service client, there's a function called setCurrentUser where you can give those 2 bits of information and rehydrate an app service client. And then on top of that, I can now use my particular API app. So if you notice here, I have a nice strongly typed create method as well. So one thing that we do in our code gen is we create helper methods off of the gateway. And then you don't have to use these, but what this does is we flow the token automatically. So if you new up an app service client and give it a Zumo token, when you say create Azure Cards client, we create the Azure Cards client, which is another API app behind the same gateway, and we just flow the token for you. You don't have to do this. I could have done new Azure Cards client, and that would have been fine too. But then I would have to be in the business of making sure the token shows up in the header. That's the only difference. So these are some nice convenient methods that we give you. Otherwise, you just see your the same stuff, deck new, deck shuffle. So let's go ahead and run this. Oh, startup project. Okay, so now in a WinForms app, here's my AD login. Okay, I'm going to log in. And not nearly as pretty as the other one, but my deck ID and my cards, again, which looks suspicious, but there they are. All right. So now let's briefly talk about that ad hoc SSO. So now let's say after I run this deck shuffling or this deck shuffling, I want to actually store the results to Dropbox. So you can imagine in real life, this wouldn't be a deck shuffle. It could be a scheduling algorithm. And after you run the scheduling algorithm, you want to store it to Dropbox. What kinds of things are in the platform to perhaps make that easier? So the big one is around auth. So I've commented out some code in here. Let me expand it. And remove these if falses. Explain what's going on here. Okay, so now what I want to do is save to Dropbox when the user says save to Dropbox. So we've tried to reduce how much code you have to write here as well. And let me pull this up. So if you see here, off of that same app service client, we have a method called getConsentLink. So this is that ad hoc SSO I was talking about. So when you add a connector, one of the things you get is a registration in the consent server. And that basically describes how OAuth works for that particular provider. So we know how Dropbox OAuth works. So when you say getConsentLink here, you're getting a link, which once you traverse the user to, will ultimately result in a Dropbox token in that server-side token store. And we can do the server-side without you having to write code to handle the OAuth flow because we know how Dropbox OAuth works. We have a declarative way of doing it. We haven't yet opened it up to partners. But it's something we hope that will work with any provider that does OAuth 1 or OAuth 2. So that's what's happening here. Then all I'm doing is navigating the browser to it. And then up here, up here, when I hit, and here the return URI, I can give it whatever I want. So here I just said foo. It doesn't really matter. So so when the browser hits foo, because that's what when I said getConsentLink, I specified foo. When the browser hits foo, I'm going to look at the URI, same pattern again, #token. And once I have that, there's now a token in the token store on the server side. With that token, I have two options as a pro dev. One option is to use the connector, which, quite honestly, in many cases, doesn't make sense as a pro dev. If the provider has a good SDK, what's the point in calling a connector that will then call into Dropbox? Having said that, Dropbox doesn't have an official .NET SDK, so in this particular case, this was kind of convenient for me. The other way you can use this token is on the server side. So if you're using mobile apps, formerly mobile services, from right inside your mobile app code, for example, you can call a very similar method to get the Dropbox token. And then on your server, you can still use the Dropbox SDK, but pass in the token that was acquired using our infrastructure. So either approach is possible, but for most cases, I think as a pro dev, I would probably use the provider's SDK, but I still appreciate not having to do the OAuth flow myself, having this infrastructure do the OAuth flow. So let's go ahead and see if it works. So Control F5, I have the right startup project. Okay, I'm going to log in again. Okay, I'm going to log in my AD credentials. Okay, so now I'm going to save these shuffled cards to Dropbox by pressing this button here. Okay, it brought up the browser control, and it took me to Dropbox. Okay, I'm not sure what happened here. I might have had cached credentials, but it did. You can see it did take me to the Dropbox. It did take me to the Dropbox site, and it should have prompted me for credentials. I'm not sure what went wrong. Take a quick look. And interestingly, I got the two-factor auth notification here, so something, it almost worked. But anyhow, you get the point. Yeah, maybe it was on Dropbox's site. It's possible. All right. What would have happened is the file shows up in my Dropbox. Okay, one final piece is back in the portal, just like I had an API app for Azure Cards, I have an API app for the Dropbox connector. Okay, if I go to All Settings, there's a tab called Authentication, and here's where I can enter my client ID in secret. So, as a pro dev, you still have to go to the Dropbox portal and register, but instead of writing code for handling the token flow, you just paste in the client ID in secret here. And if you do this, logic apps, when you drop in the Dropbox connector, will do the same thing as well. All right. We have about 6 minutes left, so let me just briefly talk to Node, and then I'll show you a quick logic app sample, and then we'll break. All right, so another thing I can do with all these API apps is orchestrate them in logic apps. So I went ahead and created an empty one. I think this is empty. And I'll show you a couple of things here. So there's two kinds of logic apps. The first ones are ones that are triggered. So those are triggered either based on some kind of event. The event can either be an event that's polled for, like I poll a SQL database every minute for a new record, or it can be a push, like lots of providers support webhooks, so you can call an API, and when that happens, that will get triggered. So in the case of Twitter, that's certainly something we support. So let me go ahead and click Twitter. Okay, we understand the OAuth flows, as I mentioned, so I can click Authorize. Hopefully I have better luck here. Okay, Authorize app. I was already logged in. Okay, and I can trigger based on new tweets. So for example, I can Twitter, whenever a tweet shows up with my name in it, the workflow will get kicked off. The other way I can do it is just manually. So if I do this checkbox here, I can orchestrate a bunch of steps to run manually. So let me go ahead and use Brady's Azure cards again. And here's where you can see, here's another example where you can see the power of the metadata. So just via swashbuckle, I can see all the operations that are available on Azure cards. New deck, shuffle deck, and deal deck. So let me go ahead and do new deck. It says this operation has no inputs, which is correct. Hit check. It has one output, which is body. Now I want to feed that output into Azure cards again. And I want to, the shuffle algorithm doesn't work anyway, so screw that. I'm going to just, I'm just going to do deal. Okay, deck ID. So deck ID is from the previous step. It's the output of deck new, and I can specify how many cards I want. So let's say I want 5 cards. I hit check. And then let's say when it's done, I want, let's just do 1 card for this purposes of this, because I don't want 5 text messages. So let's say 1. And when it's done, I can say, hey, text me that this algorithm has run and it's produced some output. So with Twilio, I can enter my phone number, my from phone number. My to phone number, and a text, which can borrow from the previous steps. It's like the face. Hit check. Save it. And I can do run now. And my phone's on. Let me do it one more time. I actually got the text message, but my phone was not on. My phone was on silent. So run now. There we go. So kind of cool. Like even as. Thank you. So hopefully that helps you kind of make sense now of why App Service has these different pieces. But you can see how API apps with metadata can power a bunch of the experiences. Couple final things. We have about 2 minutes left. I didn't get a chance today. Our story is certainly not just .NET. So if you go to windowsazure.com, documentation, web and mobile, API apps. We have a bunch of articles, and the set is increasing. It's all on GitHub, so you can contribute to. We have an article on Node, and an article coming out in the next day or two on Java. So if .NET is not the only language you use, you can certainly use other languages, and the instructions are up here. Another demo that I wanted to show, I'm going to show this one really, really fast, is the hybrid scenario. So I have an on-prem SQL database here called Bob Store. And I can expose an API in the cloud using the same technology. I call this API local data Bob. It's an ASP.NET application that just wraps the database. It has metadata on it. I can go ahead and run it and say /API/products. This is IE, so it makes me download the JSON file. But what comes back is the output from my local database. So it's another kind of powerful scenario that I can include in my APIs is a hybrid connection. There's two technologies that are supported by web apps. One is a VPN or VNet VPN, and the other one is hybrid, which is through Service Bus. Either one is supported. All right, so I think we're out of time. Thank you for being a great audience today. Appreciate it. Definitely appreciate your feedback. I think there's a slide in here for that. There it is. There's a slide in here for feedback, so please submit feedback. And then, huh? Oh. And then feel free to come up and ask me or Brady if you have any questions. Thank you.